Hello, everyone, and welcome back. Today, we're going to talk about adding rational expressions. We're going to be doing two examples today. So, for this first one, we have 3x over x plus 2 over x minus 2. So, our very first step when we're adding rational expressions is we need to get the denominators to be the same by multiplying them so that they have a common factor. So what we're going to do is we're going to take this first fraction, 3x over x plus 2, and I'm going to multiply numerator and denominator by x minus 2. And then for our second fraction, which is 2 over x minus 2, I'm going to multiply top and bottom by x plus 2. And the reason I'm doing that is because I want both denominators to be the same. And if we only multiplied the denominator in the first one by x minus 2 and the denominator in the second fraction by x plus 2, both denominators would then just be x plus 2 times x minus 2. And that's what we want. Okay, so now I'm going to multiply through, and we're going to get 3x squared minus 6x. Don't forget to use the distributive property here and multiply the 3x by both x and by negative 2. And that's going to be over x plus 2 times x minus 2. Then for the second one, we use the distributive property again, and we get 2x plus 4 over x minus 2 times x plus 2. Now I'm going to combine them both into a single fraction because they both have the same denominator. So just like all fraction addition, the denominator will stay the same. It'll be x plus 2 times x minus 2. And the numerators will be added together. So we're going to get 3x squared minus 6x plus 2x plus 4. Then for my last step, I'm just going to simplify the numerator. I notice I have negative 6x plus 2x, and that can be simplified to negative 4x. So my final answer is 3x squared minus 4x plus 4, and that's all over the denominator of x plus 2 times x minus 2. So there's our final answer for this one. Now the restrictions would be that x cannot equal 2 and x cannot equal negative 2, because if x is either 2 or negative 2, then we end up with a 0 in the denominator, and we can't have that. Okay, let's move on to the second example right over here. So something I notice here right off the bat that's different about this question is that one of our denominators actually can be factored. It's a difference of squares. So that's my first step here is I'm going to factor it, because it might turn out that we have a common factor here already and that we actually might have to do a little bit less work to get the denominators to be the same. So if we factor this using the difference of squares formula, well, actually, let's recall what's the difference of squares formula. Recall the difference of squares formula is that a squared minus b squared is equal to a minus b times a plus b, like that. So therefore we have x minus 5 times x plus 5, like that. And so we actually have one common factor in both denominators, which is x plus 5. So all we have to do to get the denominators to be the same is multiply the first fraction by top and bottom by x minus 5, because we already have the x plus 5. That's already good to go. We just need the x minus 5 to get them to be the same. So in my next step, I'll write x over x plus 5, and then times x minus 5 over x minus 5. And then over here we have plus 4x over x minus 5 times x plus 5. And then that is equal to x squared minus 5x, if we multiply the x through, over x plus 5 times x minus 5. and then plus 4x over x plus 5 times x minus 5. So now we have both denominators the same. So in the next step, we can combine these fractions into one big fraction with a denominator of x plus 5 times x minus 5. And then in the numerator, we just add them. So x squared minus 5x plus 4x. And then in my final step, I'm just going to simplify the numerator by collecting like terms. So we end up with x squared minus x over x plus 5, x minus 5. And if we were able to factor the numerator in such a way that we'd be able to cancel out any of the factors in the denominator, we also would want to do that. In this case, technically, we could factor the numerator. We could say, well, the numerator actually is x times x minus 1. That would be true, but it's not like that would actually help us any further. So we can actually stop here for that reason. So that's our final answer. The only thing left to do for this one is to just quickly write the restrictions. So x cannot equal to 5 or negative 5, because if it did, we would end up with a 0 in at least one denominator at some point, and therefore those values are restricted. But that's all for this one, and we'll see you for the next one.